A century ago, Edwin Hubble shattered humanity's perception of the universe by discovering a flickering star, V1, in the Andromeda Galaxy. He proved that our Milky Way is just one of countless galaxies in an ever-expanding cosmos. This groundbreaking discovery marked the birth of modern cosmology and forever changed our understanding of the universe. In this video, we'll explore the science behind Hubble's discovery, why it matters, and what it teaches us about our place in the cosmos. Let's go back to 1923. At that time, many astronomers believed the Milky Way was the entire universe. Spiral nebulae like Andromeda were thought to be clouds of gas-forming stars within our galaxy. Enter Edwin Hubble, armed with the Carnegie-funded 100-inch Hooker telescope, the most powerful telescope of its day. One night, Hubble observed a star in the Andromeda Nebula that flickered in brightness. This wasn't just any star, it was a Cepheid variable, a rare type of pulsating star. Thanks to Henrietta Swan Leavitt's earlier work, astronomers knew that the pulsation period of a Cepheid variable was directly linked to its true brightness. By comparing its intrinsic brightness to how faint it appeared from Earth, Hubble determined that this star, and thus the Andromeda Nebula, was far beyond the boundaries of the Milky Way. The result? Andromeda wasn't a nebula but an entire galaxy over 2.2 million light-years away, a value later refined to 2.5 million. Hubble's discovery blew open the doors to a much larger universe. What was once considered a single galaxy now became a cosmos of countless galaxies. Hubble was so astonished by this finding that he marked the photographic plate with an exclamation point. This discovery didn't just expand our understanding of the universe, it fundamentally redefined it. Hubble didn't stop there. By studying the light from these galaxies, he noticed something extraordinary. The light spectra showed a redshift, evidence that galaxies were moving away from us. Moreover, the farther a galaxy was, the faster it appeared to be receding. This relationship became known as Hubble's law, later formalized as the Hubble-Lemaitre law after Belgian physicist Georges Lemaitre independently theorized the expanding universe 2 years before Hubble's observational confirmation. The proportionality between a galaxy's redshift and its distance laid the foundation for the concept of an expanding universe, a revolutionary idea that overturned the static universe model favored by many, including Albert Einstein. Einstein himself had earlier introduced a cosmological constant to maintain a static universe in his equations. When Hubble's work confirmed the universe's expansion, Einstein famously called the cosmological constant his greatest blunder. This discovery also supported Lemaitre's theory of the Big Bang, suggesting that the universe began as a singular hot, dense point that has been expanding ever since. This expansion isn't just a movement of galaxies but an actual stretching of space itself. Hubble's findings also introduced the Hubble constant, which quantifies the expansion rate of the universe. Determining this constant accurately remains a critical focus for astronomers as it helps estimate the age of the universe, now believed to be 13.8 billion years. Edwin Hubble's discovery not only reshaped our understanding of the universe in his time but continues to influence modern astronomy in profound ways. To this day, his legacy is carried forward by advanced telescopes and groundbreaking research pushing the boundaries of our knowledge of the cosmos. The most iconic testament to Hubble's work is the Hubble Space Telescope, launched in 1990. Orbiting Earth far above the distortion of the atmosphere, this telescope has provided unparalleled clarity in observing distant galaxies, nebulae, and stars. Its observations have expanded the cosmic distance ladder that began with Hubble's Cepheid variable, allowing astronomers to measure distances to galaxies billions of light-years away. These measurements have refined our understanding of the universe's expansion and the Hubble constant, the rate at which galaxies move apart. One of the telescope's most transformative contributions came in 1998, when observations of distant supernovae revealed that the universe's expansion is not slowing down as previously thought, but accelerating. This astonishing finding pointed to the presence of a mysterious force known as dark energy, which is now estimated to make up about 68% of the universe. The discovery of dark energy has become one of the greatest puzzles in modern physics, sparking new theories and experiments to understand its nature. This telescope has also introduced us to some of the universe's earliest galaxies through projects like the Hubble Deep Field and Hubble Ultra Deep Field. By peering back in time, it has allowed scientists to study galaxies that formed mere hundreds of millions of years after the Big Bang, providing a window into the early stages of cosmic evolution. These observations offer clues about how galaxies, including our own Milky Way, formed and evolved over billions of years. The James Webb Space Telescope is already building on Hubble's findings by studying the universe in infrared light, revealing details about the formation of stars and galaxies obscured by cosmic dust. Meanwhile, the upcoming Nancy Grace Roman Space Telescope is poised to tackle one of the most pressing questions in modern astronomy: the precise nature of dark energy. By conducting massive surveys of galaxies and studying phenomena like gravitational lensing, the Roman telescope will help refine our measurements of the Hubble constant and may resolve the discrepancies that currently puzzle astronomers. From Cepheid variables to dark energy, Edwin Hubble's contributions resonate deeply across time. The story of V1 and Andromeda isn't just about discovering other galaxies, it's about unlocking the mysteries of the universe, one observation at a time. As we continue exploring the cosmos with cutting-edge tools and telescopes, we're reminded that the quest for knowledge is endless and that every discovery is a step toward understanding the grand story of the universe. Thank you for watching. If you enjoyed this video, don't forget to like, subscribe, and share your thoughts in the comments below.